This is EGME-331 solid mechanics. In this video, we'll be reviewing fatigue. So fatigue is a failure mechanism that involves the cracking of materials and structural components due to what we term as a cyclic stress, or you can term it as fluctuating stress. So while the applied stress could be tensile or compressive or torsional, it could be any different stress. The crack initiation and propagation in the case of fatigue would be primarily due to the tensile component of the stress. And one of the most interesting factor about fatigue is that the cracks caused by fatigue is initiated and also propagated at stresses that are well below their yield strength. That means we are talking about somewhere in the elastic region. That means these stresses are usually related to elastic deformation and not plastic deformation. Now we have three stages of fatigue failure. The first stage is termed as the crack initiation. Here, the fatigue cracks initiate at a free surface or near a stress riser, or any point where there is a joint or there is a deformity. Those are the points where the stresses are high, and that's where the fatigue crack initiates. Now the initial development of the fatigue crack prefers discontinuities. We can also term it as localized discontinuities. And in general, in mechanics, we term these discontinuities as things that increases or enhances the strength of the metal. And this happens because of plastic deformation. Now, we are talking about discontinuities which are present in the metal or the metallic structure, and this causes a plastic deformation leading to strengthening of the material. This whole process is what we term as the work hardening. Now the problem here is the fatigue is a cyclic process, which means you repeat the process again and again, and at some point the material loses its ability to plastically deform, and that means the material reaches its peak of plastic deformation limit, and from there the discontinuity starts becoming a small crack. So this is what we term as crack initiation. In the stage 2, we term it as crack propagation. So once the crack is initiated, the continued cyclic stresses repeat the process and then slowly growing it into micro cracks, which becomes a threat to the structural integrity of the material. And the last stage is the actual failure, stage number 3. Here the final failure event we can also term as the catastrophic failure or catastrophic fracture. It could happen either in ductile or brittle mode depending on the material properties, thickness, temperature, even applied stress. Now the fatigue failures typically they occur suddenly. That means once the limit is passed, it's a sudden failure, which is not a preferable or favored thing for most engineering structures. However, in case of fatigue, you are experiencing a sudden failure. Also, we have seen that the fatigue-induced fracture surfaces, when we inspect the broken components, but we could see they are typically smooth and does not show any evidence of plastic deformation. Now, there are several factors that affect or influence the fatigue strength of a material, and this includes a range of stress, the geometry of the component, the material properties, and even environmental factors such as the thermal as well as corrosive conditions. Now the fatigue properties can also be improved by increasing the thickness of the component. The problem here is the increased thickness can result in the final structure being more brittle rather than ductile. Now let's take a look at SN curve. So what is SN curve? So fatigue strength and the fatigue life are like two critical parameters that are used to describe the fatigue behavior. Now we have seen like there are tests that show the relationship between the stress, which is termed as the S, and the number of cycles to failure, which is termed as N. So S stands for stress and N stands for number of cycles to failure. And we could do this test on any component that you want to inspect. So what we see here in this graph is what we term as the SN curve. And here we could see the fatigue limit of the given material.